Okay, so today we are going to be doing combustion analysis. This is a pretty tricky topic, and so I've already written it out, and I have these little notes on the left side. So we're going to be kind of formulating, we're going to be formulating the formulas. I'm going to give you a step-by-step guide on how exactly you're to go about this, the first steps, and everything in that general area. And I have it color-coded too. So if you look at it now, we can see there's blue and there's red. Blue is referring to the carbon that we're going to be finding. Red's referring to the hydrogen that we're finding. And later on, there's pink for the oxygen. Okay, so first and foremost, formulas. You're going to be writing out your formulas, and you want to see exactly what's happening in the question. So you want to read the question out, and we see that there's only carbon and hydrogen. I dive into oxygen later. Only carbon and hydrogen. It reacts with O2, and it forms 13.725 grams of carbon dioxide and 6.42 grams of H2O. Okay, so when we see this, our first instinct is to think of the Stoke graphs, okay? And what do we want when when we're looking for empirical formulas? We want to get the moles of the carbon and the hydrogen and eventually the oxygen. This one's more simple. We're just gonna be looking at the C and the H for right now. Okay, how do we do that? Well, you're gonna be thinking of your A to A and your A to B. So you're gonna be looking at each and determining what all exactly you need to do. So for this one, we're going from grams of CO2 to moles of C. So the C is already included in the CO2. So there's not going to be that many crazy steps going on. So grams of CO2, and so in order to get rid of the grams and to go to moles so that we can go to our mole to mole ratio, we need to find this number right here. And to find this number, pretty sure everyone in this class knows how to do that. Okay. Now you find your mole to mole ratio, which for this is just 1 to 1. You ask yourself for this ratio right here, you ask yourself, how many of these are in one of these? It's that simple. It's 1 to 1, 1, 1. And if you add all this together, you get 0.3119 of C. Now, remember this. That's why I have it color-coded. Remember this number. This number is important. We're going to be using this later on for the entire question, okay? Now, next, hydrogen. So we start off with 6.742 grams of H2O. Now, we're going to be moving it to moles. So we need this. It's the same one from up here. We found out this number. Easy peasy. 1 over 18.016. So now we found our mole ratio. Now, the mole ratio for H2O, you ask yourself, how many hydrogens are in H2O? There's 2. So you add all these together, and you go through, you get 0.7484. Now, next, empirical formula. So, to find the empirical formula, you're going to divide both products by the smallest. Or, eventually, it's going to be all 3 of them by the smallest. The main goal is to get a 1. You want to get a 1 in there. So if there's a C, an H, and a O, you want to get that C, or whichever one's the smallest. You want to get at least one of them to C1 or H1 or to O1, and then you're going to go from there. Okay, that's the easiest, because you don't want to be dealing with a bunch of different decimals. You want to get one of them to 1. So we look at these two. Which one's the smallest? Pretty hard question, huh? It's that one. So color-coded. So we have C over C, right? To get the moles of C, that's obviously 1. So we're going to have C1 down here. And you have 0.7484, which is the hydrogen, divided by the carbon. That's going to get you 2.4 moles of hydrogen. We have 1 mole of carbon. Put that over here. C1, H 2.4. Obviously, we can't have a 2.4. We just can't. That's stupid. You can't have 2.4 of an atom. So we're going to be finding, you're going to obtain whole numbers, and you're going to find the easiest number that's going to go to it. It has to be intuitive. You have to do it enough, and you have to practice enough for it to be intuitive. But a good rule of thumb is you want to multiply by the lowest number. That's going to get your decimal to a 0 at the end. So you have a 4. How do you get to a 0 with a 4? multiply times 2, you get 8, multiply times 3, you get 12, 4, 16, 5 equals 20. There you go, that's good. So you get 20 with this, you get 2.0 with this. 2.0 plus 5 times 2 is 10, 12. That doesn't matter. It's intuitive. Don't listen to all that stupidness I just said. You just want to get the lowest possible number. I have faith in all of my classmates that y'all can do this, okay? Okay, next. Here's where it gets a little tricky. Oxygen. So CHO, when it says that, it has, so you're trying to find C of X, H of Y, O of Z, and not just C and H, it gets a little bit more tricky. All it does really is add one more step. You're gonna find the total weight of C plus H in the product. So in that situation, it was CO2 and H2O. The C of CO2 and the H of H2O, those all have to come from the CHO molecule. They can't come from the O2, because obviously you can't just create something from a totally different substance. So it all has to come from the CHO. So you find all of that from the products, and you minus the CHO molecule's weight by that. And by the law of common sense, you're going to be left with the oxygen left. Okay? Just think of that. It's all common sense, really. You gotta think common sense. You have to think through these Stoke maps. Okay? Okay. So we're gonna think of this now in terms of variables a little bit, just to make it more blanket statement. Okay? So we have X grams of CO2. And we're gonna move these grams into moles with our molar ratio, with our gram to mole ratio. Then our molar ratio of C to CO2 is just 1. Just as last time. All of this, and eventually we get some other variable, some other number. Okay? We're gonna do the same for H2O, and we're gonna get these two variables. Okay? So eventually we're gonna find the mass of this, and we're gonna minus the mass of the carbon, the mass of the hydrogen, and eventually we're gonna find the oxygen. It's that simple. Okay, once you find C and H, you can find O. Now here comes a little bit. I said bonus, and I was trying to make this all happy. That's just so that y'all have a fun time. Y'all are gonna need to know this for the test, or you're gonna get points off. Okay, this is important. All right, molecular formula: if molar mass is equal to 360.385. So this is for the last one without the oxygen in it. Same things still apply. If you have oxygen in it, you just do the same steps, but do it to the oxygen as well. Okay, so what do we know and what do we want? This is important to write down for every question that you do. We want 360.385 grams per mole. We know that the empirical formula is C5H12, and we know that C is equal to 12.01 grams per mole and H is equal to, we know this. Now here comes the most important step. If you know the like these few steps, this last part is not going to be that hard to you. You're going to find the current grams per mole. So we have C5. You just need to know what to put together. So if we put these two things together, through right here, C times 5, H times 12, we get this number. This number is our current. This number is our target. So if we want to get to this, and we have this, we need to know what to multiply everything by in order to get that. And that's this magic number right here, okay? So you have your target divided by your current, that's gonna give you a 5. Now what do we do with this 5? Well, obviously, you just multiply everything times it. C5H12 times 5, you get C25H60. That would be the molecular formula as opposed to the empirical if the molar mass was 360.365. Now we are going to move into